Hi everyone, I welcome you all in Tutorial 5 of my ETABS software training series. In last lecture, we discussed how to assign dead loads and live loads onto your structure and how to read the loads from code books. If you haven't watched my previous tutorials, don't worry, I will paste a link in video description so you can access to my previous tutorials. If you are new to my channel, please subscribe to it and press the bell icon so you can be notified on my next uploads. In this tutorial, I will discuss about two topics. First is how to assign seismic loads using ASCE 716, IS 1893, Building Code of Pakistan, and UBC 1997. As the seismic provisions of Building Code of Pakistan are compatible with the Uniform Building Code 1997, so I will use Pakistan Building Code to extract seismic coefficients. In similar way, you can read the data from UBC code. And the second topic is how to define mass source for considering lateral load and seismic design of building. As we are done with assigning the gravity loads in our last tutorial, so we will move to assign the seismic loads. We will start with Indian standards. So how to apply the seismic loads? Go to the define menu, choose load pattern. So seismic loads mean they are the earthquake loads either in X direction or Y direction. So we have to assign these loads in both directions. So type EQX, choose seismic, select IS 1893-2016, click OK. Similarly, earthquake in Y direction, type seismic, similar code, add new. Now we have to modify the parameters. To modify the parameters, click modify load, modify lateral loads, uncheck all these parameters. Now from the code book we have to define the zone factor. For example, if we are designing a building in a Bombay region, so go for Indian standard 1893 part 1. So I have older version 2002, but in ETABS we have selected 2016, so there will not be much difference. So if we are designing the building for Bombay region, how will we do? First we have to define the zone factor. So type Bombay, type Mumbai. So Mumbai is in zone 3 and the zone factor is 0.16. The value of Z is 0.16. So go to ETABS model, select 0.16. Site type. Again go to the code book. Select site. Or choose manually. Yes. Site type means whether the soil type is rock or hard soil. So this data will be given to you from soil investigation. So for example, I am considering soil type. So importance factor. So important factors mean whether it is a residential building, school buildings, public offices, banks, hospitals. So in this way, the buildings are categorized based on their importance factor. So in order to find importance factor, just write importance and click next several times. So here you can read important service and community buildings such as hospitals. Our building is not hospital. Our building is not a school building. So for such cases, we have to use 1.5. For all other buildings, use 1.0. So our building lies in all other building categories. So we will choose 1. And now the response reduction factor. Again, the code has specified these values. Go to the code value again, type response. So first we have to define what type of building frame system is, whether it is ordinary RC moment resisting frame or a special RC moment resisting frame. In simple words, if I tell you the difference between these two is of the shear reinforcement. If the shear reinforcement is high, if the building is designed for high seismic zones, so we will go for special RC moment resisting frame. So for that, the code suggests the value to take as 5. For ordinary RC moment resisting frame, for example, if the building is to be designed for low seismic regions, then we have to use reduction factor as 3. So as you can see, by default the value 5 is inserted here because ETABS consider you are going to design as a special moment resisting frame. So we are choosing 3 here. So click OK. So in similar way, you have to change the values in Y direction. So to change the values in Y direction, you have to click EQY, click modify lateral load, and you have to uncheck all these parameters and check Y direction only. As per our zone factor value, it was 0.16. Our site type we selected was 2. Importance factor, as we are dealing with residential buildings, so importance factor is 1. For time period, I will always recommend you to go for program selected value. Don't go for user defined or approximate value, because if you compare the value with manual calculations, the values will be different, as the ETABS consider stiffness in the count as well. So always go for program calculated value. Similarly, in story range, some users go from base to story 3 and some users go from story 1 to story 3 because our base is embedded in the ground. So whether you choose from base or story 1, it is fine. I always choose from base to story 3. So for response reduction factor, as we saw from the code value, it was 3. So choose this value. Now what is the response reduction factor? Let me define it. So it is the factor by which the actual base shear force is reduced. In simple words, it reduces the earthquake load which is encountered by the building by the factor we input in this seismic coefficients. For example, if we are choosing response reduction factor 5 and the earthquake load is 1000 units in actual, so this reduction factor reduces to 1/5 of the actual value, and the building is designed to experience only 200 units of earthquake. Now the question is, why we do so? Why we reduce it? As we know, you can see from strain stress diagram of a steel. So as we know, we always consider the properties of material and linear elastic range, and we always ignore the plastic strength of material. We always design our building considering the yield strength of material, but in actual, the structure has capacity to take the load up to strain hardening region. So that is why we reduce the actual base shear by certain value, because we know after yield point our structure has capacity to resist the earthquake, and this makes our structure earthquake resistant. Earthquake resistant structures mean it can experience small cracks in the buildings, or some building component may also collapse, but overall the structure will respond well against the earthquake. Now if we say earthquake resistance, now the question is how we design earthquake proof structures. So to do that, just type 1 in response reduction factor input, but we don't go for this value as it will give high reinforcement for our building, and the structure will be uneconomical. So choose the value which is recommended by the code. Click OK and OK. So we have successfully inserted all the parameters, seismic coefficients using ASCE code. Now I will refer to Pakistan building codes. But the problem is ETABS 18 version does not support UBC codes. So for those aspirants who use ETABS 2016, so first I will open a screenshot of seismic coefficients from ETABS 2016. So as you can see in this picture, we have to define these parameters if we are using UBC 97 code. First we have to define what type of soil is. 6. Soil profile type. SA, which is described as hard rock, SB, which is rock, SC, very dense soil and soft rock, SD refer to stiff soil profile, and SC refer to soft soil profile. So you have to choose. This data will come out from soil investigation. For example, our building lies in ESP region, so you have to choose SP here. Now we have to look for the seismic zone factor. For example, if I have to design a building in Hyderabad region, which is located in province Sindh, so first let's refer to Pakistan building code. So for Hyderabad region, first we have to see in which zone Hyderabad lies. So Sindh, in province Sindh, search for Hyderabad city. So Hyderabad city is in zone 2A. Okay, now go and find zone factor. So for 2A we have to put value 0.15. So in this dialog box we have to put 0.15. Now you have to define the values of CA and CV. Again go to the code book. For CA and CV, they are basically seismic zone factor. So for soil type B, zone 0.15, so the value of CV is 0.15 and the value of CA is 0.15. So you have to insert 0.15 in the section of CA and 0.15 as well in the section of CV. Now importance factor. So important factor will be 1 because this is a residential building. We can also verify this from our code book. Standard occupancy, all structure housing occupancies and having functions, so I value is 1. So you have to insert 1 here. Over strength factor R. Again refer to the code book. So for R, our building, our structural system is moment resisting frame, and in the category of moment resisting frame it is an ordinary moment resisting frame, concrete, so we have to choose 3.5. so just type 3.5 here. So in this way you have to use UBC code and find out all the coefficients from UBC code in and insert all the values in seismic load pattern. As we are going to design our building using ASCE ACI code, Go to the define menu, select load pattern, choose ASCE 716, click modify load. Similarly in Y direction, choose ASCE 716, click modify load. Uncheck all other parameters. I will discuss these parameters in advanced topics. Now we have to look for these values. First, define site class. First we have to look for the site class from ASCE code. So site class, site class. In site class we have to find the values of A and FP. If you just insert site class as C, so ETABS will by default will take the value from code. So let's verify. If you choose site class B, so site class B, so FV is 0.8 and FA is 0.9. FV is 0.8 and FA is 0.9. So following this we have to find the values of SS and S1. So SS is 0.5 and S1 is 0.2. 0.2 and 0.5. Longer period transition means, so this value is used for high-rise buildings. If it is more than 4 or 5 story building, so you have to use, whether you want to design a building for 10 seconds time periods or 11 seconds time periods. Basically this is advanced topic. You must have some basic know-how about earthquake engineering. So just write 8 here, or you can also write 10 here. It's up to you. Now response modification factor. Again, as we did in IS code and Pakistan building code. So for ordinary moment resisting frame, so moment resisting frames, we are using ordinary reinforced concrete frames. For ordinary reinforced concrete frame, the value is 5. Overspring factor is 3 and deflection amplitude is 4.5. Deflection amplification is 4.5. So 8, 3 and 4.5. Click OK. And you have to do the same in Y direction as well. Uncheck all these parameters. Zero 0.5, 0.2, 5, 3 and 4.5. Click OK. Now let's discuss about mass source. This is very essential for considering lateral load and seismic design of buildings. This means how much seismic weight should we include for calculating the base shear. So let's see what are the provisions in ASCE 716 manual and IS Indian Standards Building Manual. So somehow the values are same in all the codes which you follow, but let's compare it. Go and open ASCE manual. So first type the base shear and you will be here. So here you can see the equation for base shear is written. which is V is equal to Cs into W, where Cs is seismic coefficient and W is seismic weight. So how much seismic weight do we have to include into our structure? So for this you have to click W is the effective seismic weight per section. So how much weight should we include for our lateral load calculation? So click this link. So it will bring you to the section 12.7.2 where effective seismic weight criteria is given. So read this criteria. So the effective seismic weight W of structure shall include the dead load as defined in section 3.1 above the base, and other loads above the base are listed below. So you have to include all the dead load which is included in our structure. For imposed loads, the conditions are given. In areas used for storage, a minimum of 25% of the floor live load shall be included. So 25% live loads you have to include. So there are some 10 exceptions also written, where the inclusions of storage load adds no more than 5%, so then you can neglect the seismic weight. So it need not to be included in the effective seismic weights. As I said, you can neglect the value. Similarly, floor live loads in public garages and open parking structures need not to be included. So second is where provision for partitions is required by section 4.3.2 in the floor load design, the actual partition weight or the minimum weight of 10 psf of floor area, whichever is greater, so that you have to include in your masters. For example, so we might have seen wooden partitions and or glass partition in office buildings. So in that case you have to include 10 psf uh, of the floor area into the mass source calculations. Total operating weight of permanent equipment is if there is any machinery operated in the building, so you have to calculate the load of that as well. So in case of snow load, you have to take 20%, and similarly weight of landscaping and other materials at roof gardens and similar area. So the conditions are written. According to these conditions you can define the parameters in mass source option and ETABS. So I will tell you how to specify these conditions in mass source options. Now let's compare with Indian codes. So again, for base shear, just type base shear in the search option. So it will bring you to this option. Again, the equation is same. VB is equals to A is W. So W is the seismic weight. AH is the horizontal spectrum value. Again, it is a seismic coefficient. So for W seismic weight, you have to refer to 7.4.2. So let's move to 7.4.2. So this is 7.4.2 seismic weight of building. The seismic weight of the whole building is the sum of seismic weight of all the floors. So the seismic weight of floors. Seismic weight of each floor is its full dead load plus appropriate amount of imposed load. So you have to include the full dead load in mass source calculation plus appropriate amount of imposed load as specified in section 7.3.1 and 7.3.2. So let's go to these sections. For various loading classes as specified in IS 875 R2, the earthquake force shall be calculated for the full dead load plus the percentage of imposed load as given in table 8. So for the percentage of imposed load, we have to refer table 8. So let's go to table 8. You have to move down a bit. So this is table 8. Percentage of imposed load to be considered in seismic weight calculation. So if the live load is up to or including 3 kN per meter square, you have to include 25% of live load, and the similar value was specified in American code. If it is more than 3, you have to include 50% of live load in your base shear calculation. So let's go to ETABS and define the mass source over there. So go to define menu, click mass source. As you can see, ETAB by default has defined a mass source, but we have to modify the parameters into it. Go to modify show mass source. If you want to change the name of mass source, you can change by typing some name here. Let's type lateral. As you can see, there are 4 checklists parameters, so I will explain one by one. So number 1 is element self mass. That means all the self weight of structure. So that should be included. So yes, check is additional mass. Any additional mass you want to include in the mass source, you have to check this parameter. The third option is specified load patterns. That means you have to specify the load patterns by yourself, referring to the code books. So if you are referring to Indian standards, you have to refer Indian code books. If you are referring to any other country building codes, so you have to put the values accordingly. Similarly, the fourth option is adjust diaphragm lateral mass to move mass centroid by. So this dialog box is basically related with the centricity. So normally we don't do anything with this dialog box. If you want to change the values, you can, but leave as it is for this stage. So let's specify the load pattern as given in our ASCE and Indian code. So we have to include all the dead loads of the building. So select dead from this option and click add, and 25% of the live load, write 0.25 and click add. So we are done. Now there are other 3 options, so let me explain one by one. So first option is include lateral mass. That means the mass in x direction and y direction will be included. And the second option is include vertical mass. This is unchecked by default because the lateral mass in this direction is so negligible, so that's why it is not accounted in this option. And the third is lump lateral mass story levels. Basically that means all the self weight in the mass source are considered to be accumulated at story level, so you have to check this option. If you want to check these 3, it's okay, it's not a big deal. This way we have to define the mass source data in our model. So once we are done, click OK. So guys, this brings to the end of today's tutorial. If you find this tutorial useful, please do like and share. And if you have any doubt, you can comment in comment section. For upcoming tutorial videos, please do subscribe my channel and don't forget to press the bell icon so you can be notified on my next uploads. Thank you and have a nice day.